Good morning. How's everyone doing? Good, good. Well, did everyone enjoy their first talk here today? Good job. Um, it's still 9:30 in the morning, so I know hopefully we'll have a good second talk. My name is Tom Wilson. I'm Chief Technology Innovation Officer at Tabula Rasa Healthcare Incorporated, which is the company that has like 20 different names. So there's Carekinesis, Medalliance, and Capstone, and then there's Jack Russell Software, and now the JRS Innovation Center, which I launched last year, and JRS Coding School. So don't worry if that's confusing. I'm confused every single day about that. Just an FYI, if you know anyone that's looking to get into coding, we teach a 12-week immersive training January, May, September. And if they're interested, just have them reach out to us at jackrussellsoftware.com. And enough for the sort of plug. So the nature of the talk today is basically this concept of functional programming, and I'm sure everyone's heard a lot about functional programming. And you may have even heard this quote that was given by Pete Hunt in 2012, and probably a lot of other people have used this quote as well over the years, but shared mutable state is the root of all evil. Even in the talks yesterday, you heard a lot about state and the management of state and how it affects your architecture, how it affects your applications. What I want to do today is show you a couple of small little functional modules that can be used to help glue some of these large sort of pieces of your application infrastructure together. But first, why is shared mutable state bad? And there's a lot of reasons why anything's bad. Too much of anything is bad, right? But it's really easy to create bugs when you don't know who's using your data and where that data is going or coming from. Shared mutable state, it's easy to create bugs. It can also be very hard to maintain, right? So if you have sort of this idea of constantly mutating state, it can be very hard to maintain over time, to keep track of what changes happen, undo changes, things like that. So those are a couple of reasons. I'm sure some folks can come up with some other reasons. Does anyone have a reason that shared mutable state is good? Does anyone? No? No? Okay, good. So, why do we want to look at functional programming? Functional programming is hard, especially if you've learned object-oriented or learned imperative coding. Learning to do things functionally is just sort of changing the way you think a little bit. But the end result is, especially for distributed systems, you may hear terms like stateless servers, right? Serverless. All of these things are coming up are a way for us to run applications across multiple machines, multiple data centers. And functional programming was really designed with that constraint in mind, because back, I guess it's 60 years now, they didn't have a lot of memory. They didn't have a lot of space on the machine, so they had to distribute that by default. And that's sort of why it's coming back into more of a top position now, is because, having phones like this sort of creates a constraint of distributing your app to a lot of people everywhere. And again, they want to be able to stream Netflix 40,000 feet in the air, right? In real time. So those types of things introduce constraint. But really, from a developer's perspective, functional programming really provides less bugs. It's easier to maintain because you're thinking in pure functions, which pure functions means that your input in will always return the same input or output. So it's much easier to test. It's much easier to maintain. And believe it or not, JavaScript supports functional programming. Actually, JavaScript was designed off of Scheme, and Scheme was based off of Lisp. All of these are functional programming languages, and one of the interesting things was that, and if you use JavaScript and you've used it as an object-oriented language, you probably felt like maybe that object-oriented principles and practices were maybe bolted on at the last minute, right? So in 10 days of creating a language, they may have spent 8 days writing functional programming or taking it from Scheme, and then 2 days putting prototypical inheritance, which is not anything like classical inheritance that you see in things like Java or C# and things like that. And I'm just joking, I don't know how long, but it does feel like sometimes if you use JavaScript as an object-oriented language, it sort of feels different, right? It's not the same as the classical languages. But it supports the ability to pass in functions as values and the ability to return functions out of your function as a value. So making the function a first-class citizen gives it a lot of functional programming capability. The stack that we teach and we use at the JRS Innovation Center consists of React and Redux, which I'm sure you've heard a lot about that, and Node.js and Express, CouchDB and MySQL. But what I want to talk about today is some of the smaller modules that we use, and these are opinions. I think that there's plenty of opinions in each one of these spaces, and I'm just sharing why I think these work really well for us and work well for students getting started, as well as people that need to get things done relatively in a performant and quality way. So I'm going to talk a little bit about tachyons. How many of you guys have heard of tachyons? Cool, a few of you, yep. And then Randa. How many of you guys heard of Randa? A lot of people. Probably, if you've listened to me, you're probably tired of hearing about Randa. So, but I'll talk a little bit more about Randa. And then Now. How many of you guys have heard about Now? A few, good. So hopefully this will be some interest of some others, and hopefully you'll find that these things could be pretty cool for you. So tachyons. Tachyons is subatomic classes. It's a different way to think about writing CSS. Have all of you guys written CSS, right? How many of you enjoy writing CSS every day? We've got one person, 2, 3, 4, okay. Every day you would rather just write CSS all day long. And that's great. But for those that really want the CSS to be done and get to the code, I think Tachyons is a good thing. Tachyons is actually also a good thing if you do like writing CSS and you want to be very declarative. So if you think of the idea of imperative, where you're telling the computer how to do something, functional programming is all about declaring or being declarative to your computer. You want to say, what I want you to do is this, and then let the computer figure out how to make that happen. And so that's really the theme here. And Tachyons allows you to be declarative at your CSS. So what it is a set of small micro libraries that basically give you very short abbreviation terms to write CSS. So it's not like a Bootstrap or a Foundation where you have a whole different sort of set of classes for like button or for form or for a list. It's small little subatomic pieces that you string together functionally to display your site. And when you first look at it, you may think, oh, well, that's a little verbose. But if you think about maintaining your application, and how many times have you dug into CSS trying to find the right class name where that right margin needs to be adjusted a little bit, and you go in and you make the change, and then you go all the way back to your code, make sure it's using the right class, and then you go to your form, and nothing happens, right? Or you dig into the console and try to dig through all the nesting that's going on to see which one is the right one that's being overridden at that time. Or you've made a change and it broke everything, but your thing it fixed, and you may not have known it. CSS can be very hard to manage, especially as the size of your team grows and things like that. With Tachyons, you can address it functionally and declaratively. So in this case, I'm going to create a button, and I'm going to use Tachyons to do that. The first thing that I'm going to do is define the font. And then I'm going to tell the button that it's a link, so that'll make the underline go away. And then I'm going to say I want border all. And I'm going to go padding height 3 and padding horizontal 3 and padding vertical 2. And that's just going to space out my border a little bit. And then I'm going to make it dim. So that's when I hover, it should dim. And then I'm going to change the border to green and the text to white. And then I'm going to change the border color to green. And I'm going to change the border radius to 2. Now, what's cool about that is that the padding horizontal, padding vertical, and border radius 2, all of those numbers are very similar to how heading 1 through 6 works. You can say, I want my scale to be a 0.8, or I want my scale to be a 0.16, and then Tachyons will do all the math and give you classifications of 1 through 6 that you can change on each one of your subatomic types to determine how it spaces between there. And the nice thing is for me is now I don't have to do math, right? I don't have to say, oh, this is 8, this is 16, this is 32. And some folks may be really good at that, but I'm really bad at it. And then I'm trying to adjust on different screens or different viewports. So I find having those numbers are very helpful. If I want to say margin right 3 and margin left 3, I know they're going to be exactly the same size. So the next example is sort of, what if we wanted to create a set of columns? 3 columns space. So you can use Flexbox, which Flexbox works, but I'm going to show you how to do it with floats. So we can do a clear fix by giving our parent div a CF, and then we can say for each one of our columns, float left, or FL, third, so we want a third, border all, padding all 4, and height 4. So I can take that one combination of Tachyons and apply that to all 3 columns, and I will get 3 columns separated on the screen. Now you can do a lot more with that, but I just wanted to show a quick demo. And if you wanted to do a 4th column with floats, you can just create a 4th column here. And again, right now we're saying third, but we could say 25%, 25, 25, and 25. And then we'll get 4 columns. So again, one of the things about Tachyons is that ability. I'm not having to go into a CSS file, make a change, let that change apply, then come back into my code, make sure I made that right change, and then see on the screen. I've got a very high fidelity, high feedback loop, and I'm being very declarative on how I want it. I'm telling what I want it to do, not how to do it. So the last example is an image, and this image is an avatar. FYI, if you have to always find like dummy images, philmurray.com is awesome and it's a lot of fun. So if you don't take anything away, philmurray.com, anytime you need a dummy image, is a lot of fun. So with this one, I'm going to make a border radius 100. And what that'll do is make it a circular image. And then I'm going to tell it to grow. And when I tell it to grow, that means it's going to animate, I hope, when I mouse over it, or it should. So that's a quick look. I don't know why that's not working, if CodePen or Wi-Fi or whatever.
Might have to focus that.
Yeah. And it's just a live demo, and this one's a simple one, right? But anyway, there's small little bits of animation in there. There's nothing stopping you from using Bootstrap or Foundation or anything. This can sit right on top of it, and there's nothing stopping you from writing your own CSS. Also, if you do React Native, Tachyons has a React Native plugin, so you can actually write Tachyons for React Native, which is kind of cool. And it's really, really great for tweaking around things. To learn it, you might say, well, how am I going to remember all of those macros and things like that? Well, the Tachyons website is really, really kind of cool. So tachyons.io, they have a gallery, and they have a components page, and they have documents. And all of these are small modules, so you can pull in whatever you want. You don't have to bring the whole thing in. You can just npm install piece by piece, but then you can also go to the components page, and you can look at all the examples that's been done by the community, and you're like, oh, you know what? I want a card. So let me look at all the cards out here. Oh, I like this card. And then it provides you all the tachyons, and you can literally just copy and paste that in and start playing with it. So that's a great way to learn tachyons. And again, it can save a lot of time. So, you know, why tachyons? Design systems can break as they scale. I think Airbnb has a design ops team. Okay, a design ops team. They have over 40 designers, and the design ops team actually wrote a React abstraction into Sketch, so they can actually code React to drive Sketch, so they can support all of their user experiences in the world, right, across all 40 designers to keep up. So design systems can get really hard as they scale. Systems like Tachyons approach the problem instead of limiting components. It looks at subatomic design, so you can piece those together, and you can actually build component systems off of those subatomic designs. I was doing it in line there, but they're just strings. They just sit on a class name, so you can abstract away however you want. But they become very quickly, very easy to change as you go on. And then they can be combined like Legos to create different kinds of designs thousands of ways. So that's pretty cool. So in summary, less context switching, they're functional, and they're composable, and they do math for you. So that's why I would say check out Tachyons. And here's some links. Calvin Webster created the Atom Tachyons package, which is pretty awesome. If you use Atom, you put it in your Atom install, and then you just type a command, and it'll give you the right tachyon sub-atom for you. All right, so next is Randa. And Randa is a functional JavaScript utility. If you're familiar with underscore or Lodash or a ton of other ones, Randa is one that's sort of built with a different flavor than you might be used to with underscore and Lodash. And there's a great talk by, I think, Brian Lohnstorff of Hey Underscore, You're Doing It Wrong. And he comes in and talks a little bit about Randa. But basically, the twist with Randa from those other utility libraries is that it takes the functions first and the data last. And everything in Randa is curried. Does anyone not know what currying is? Cool. So currying is the ability to essentially partially apply arguments into your function to not have to apply them down the road. So if you had a function that takes 3 arguments, you can, and I'm always talk about auto currying, because you can get into partial application currying and auto currying debates all the time. But auto currying, you can apply one or more of those arguments, but the function doesn't execute until all the arguments are applied. So they just return a function saying, if you pass 2 arguments in, it returns a function asking for the third. If you pass 1 argument in, it will return a function asking for the other 2. And once it has all the arguments in the function, then it executes. So Randa enables separation of functional logic from your presentation logic in a very testable way. Basically, a lot of times, and as we move into microservices and move into this more distributed nature, and even on the front end side with presentation, you're constantly having to take data from several different sources and orchestrate it together to fit on one page, right? So you may pull user information, you may pull your context, you may pull weather from a weather service, or you may pull restaurants from Foursquare, or you may pull all of these things together to simulate one view or one presentation. Randa is a great way to do that in a loosely coupled way. So you can separate all that logic and not have to tether that those details into your presentation framework. So I'm going to go through another short demo, and basically, not a lot of typing, but talk through it, because a lot of times, with Randa, it's like Randa's got a bazillion functions and methods. How am I going to possibly learn all of those to use it? And then the other side is I can use a for loop, or I can use array.map. And all of that's valid, and I'm going to try to show why it's worth taking the time and how you can hopefully make your code a little bit more solid and let Randa sort of do the how work for you, so you can just do the what work. So here's the basic loop, right? And we're using fetch, and we're getting the repos from GitHub that have the most stars, and actually using a wait here, which is kind of cool. Has anyone used async await? So async await, definitely check it out. But what we're doing here is calling fetch, which returns a promise, and then we're converting it to JSON, and then we're returning it to repos as if it's a synchronous call. So await allows you to make asynchronous calls look like synchronous calls, which is kind of cool. So when that returns, we get this object back, and that object is a JSON object, and it's got a bunch of items in it. And so we're going to use a for loop to print the top 5 items. So we just go through 5 iterations and print item 1, item 2, item 3. And you might think, oh, that's great, that's fine. Or you might say, let's use a for each loop, which is a little bit more declarative. The for loop is imperative, right? You're telling it exactly how to do this. I'm going to go 0 to 5, and you're going to print these things. So that basically, if you're writing your code like that, you're probably finding yourself that you're writing for loops a lot because they're one use. You can't reuse that. That's specifically for that case, and it's hard to say, oh, I need to reuse that. So what do you end up doing? You end up copying it and pasting it somewhere. So what we want to do is try to reuse code and not spend our time writing the same solved problem over and over again. So you have for each, which gets a little bit more declarative. And you take your items list, and here we're slicing it from 0 to 5, and then we're chaining for each and printing it out. We can also chain a filter on there and say, let's filter out Bootstrap. So by just using the chaining technique and saying .filter is going to return a map, and then it's going to slice, and then it's going to do a for each. So again, it'll take out Bootstrap. And that's a nice step up from a for loop. So if you're writing for loops, look at for each, because that can make your code a little bit more reusable. So this function I'm passing in now is anonymous. So I can make that dynamic. I can choose what kind of function I want to pass in for that for each. But the challenge with this is I'm still sort of dependent on these items existing, this filter being successful, this slice happening, and if any error happens in that line of code, I may not necessarily know exactly where it is. So let's look at a way to use Randa. So I'm bringing in a bunch of Randa functions from the Randa library, and we're going to use compose. Compose allows us to bind together multiple functions and make it look as one single function. It really is a different way of writing functions, and what it does is basically this top 5 returns a function that takes one argument, the data, and then it goes through and transforms that data into another result. So by using compose, you can turn your orchestration very much into like Legos, and you can say, oh, I want to grab this Lego, I'm going to grab this Lego, I'm going to grab that one, put them together, and I'm done. And all of those Legos are very focused to do one thing, single responsibility. So they do one thing, and they're very well tested at doing that one thing. So when you compose them, there's a lot less side effects or cases of maybe this is going to return the wrong thing or do the wrong thing. Also, when something does break, JavaScript is going to be nice enough to tell you what function it broke in, whether it was the pluck or the take or whatever. And in this case, we're taking the property items from the object repos, and then we're plucking name, and then we're rejecting Bootstrap, so any name that equals Bootstrap, and then we're just taking the top 5. The nice thing about compose is if you are doing, you can actually use it to optimize things. So if you're doing a lot of maps, if you find yourself doing .map, .map, .map with compose, you can just call map once and then compose all of those functions and only loop around your results once, instead of every time you do a dot map, you're doing another loop. So it's like 3 loops if you're chaining 3 dot maps. So that's the one reason you may want to look at Randa. The others here is sort of some of the same. Here I'm actually transforming the data into some string HTML, but you can quickly take these compositions and create markup with Randa and make that very readable. And in this case, I'm just doing, a compose, and I took my top 5 function, and I just added list items, right? And that list items just took a map, which took this function li, and then a join. And what's cool about that is, so my top 5 will work with virtually any JavaScript framework. So if I wanted to change from React to Vue to Angular 2, that top 5 function is going to work for all of them. And then here I'm just using strings as my li, but that could be a React component. That could be an Angular 2 component. That could be a Vue component. And I can just pull in my orchestration logic from a module and then just drop it in and call that particular transform on the component. So that's kind of cool. And I got a couple more here, and I'll share my slides and go, but I want to make sure I have a chance to demo now. And so I'm going to jump out of Randa. But before I do, is there any particular questions about Randa? Yep.
Why does it go backwards?
Why does it go backwards? This is a great question. So it has two functions. One's compose and one's pipe. Pipe will go from left to right, and compose will go from right to left. And the reason that I like to use compose is because usually I'm assigning something. So when I'm doing a compose, I think of the data sort of coming in on the right, and then it's going to this function. And then the result of that function is going to this function, and the result of that function is going to that, and eventually it's going into the variable. So to me, that's a very singular direction. Whereas if you do a pipe, you're sort of saying your data is coming in here, and then it's going up to the top, and then it's going down, and then it's returning to that. So, but it truly is a preference. And sometimes, like doing async pipelines, I like doing pipe. But when I'm composing, I'm sort of like calling this function, passing that argument into the next function, passing that argument into the next, that result in the next function. And so it actually, when you start to write it, it sort of writes more efficiently when you're thinking about it in your head. But it does take a bit of practice to get used to. Cool. Any other questions?
Is that a Randa thing?
It's more of a functional programming thing. Composition is usually takes a set of one to many arguments in an argument list, and then it will apply or return a function that takes one argument, and it'll apply that from right to left. So it's just and it goes back to lambda calculus, right?
It's
So
not Randa.
no, it's lambda calculus specific. And lambda calculus is really cool if you check it out. The guy who invented it in the 1920s actually wrote a programming language in lambda calculus before there was a computer, which was kind of crazy. But he did if statements, for loops, all of that through lambda calculus. It's kind of worth checking out. So that's Randa. And again, if you do try to give it a go, I would recommend checking out the wiki and basically this nice page of what function should I use, right? So you can say, I want to select values from the start. Use take. I want to remove the last value. Use init. So there's a lot of great helpers here for you to get used to learning this. Randa has a site of documentation. It is notated in functional notation from Haskell, so it can be a bit challenging to read. Got an open source project mainly for students that we teach to learn this stuff, and it's called Fun FP. So if you want to see a little bit more verbose description of all of the functions, I would recommend to check out Fun FP. And the other thing that I found that helped me learning this was actually writing how it is implemented. And everyone has a different learning style, but when I sat down and actually tried to write all the functions on underscore and write some of the functions with Randa, it sort of is like, you don't know how a carburetor works until you build a carburetor. It was that kind of experience. And not that anyone should use the code that I wrote, but at the same time, it helped me wrap my head around what was going on and how these things connected together. All right. Cool.
The REPL and Randa.js.
Yeah, the REPL in Randa.js is really good. So if you go to the Randa homepage from the link, you can go to the REPL, which is read eval print loop, and you can just start putting your code in there and writing Randa and seeing the response show up. So really a lot of great tools to help there. The last thing I wanted to talk about was Now.js. And Now.js is a service that deploys your code to the cloud. And it is very similar. You could compare it to Heroku or any other platform as a service, but the neat thing about it is that it's immutable. So everything you deploy is got a immutable separate footprint that will always be there until you physically remove it. So it takes functional programming and applies it to DevOps, essentially. And so being able to have immutable deployments means that if you release a build and you find out for whatever reason something's not working right, all you have to do is change the alias and you go to your previous build. So you immediately get rollback. You always keep a history, so you can go to every single release you ever did and open it up and start to use it. So you can keep a history of finding out any kind of challenges that you may have had. And it's 100% API driven, so you can connect any CI to this platform and deploy. Also, if you have a company and you want to keep these services in-house, they offer to install Now inside your cloud so that you could use it without using the public one. But from a personal project standpoint, it's very cheap. So it's free to use for like, I think 20 deployments a month, and then $15 to do like a ton of deployments a month, $15 a month. So it's very affordable. So one of the focuses with Now is really on the developer experience. And what they want to do is make pretty much one line to do just about anything. And I'm going to try to demo that to you today. I've got about 5 minutes, so hopefully it won't take long. So let's okay. Let's buy a domain. So once you install Now, you just npm install now-g, and what will happen is when you start to use Now, it will prompt you for everything you need to set up an account and everything through the command line. So you can set up your entire account through the command line, and if you wanted to deploy, so let's say make directory now demo 2. Oops. Okay. So let's just create the most awesome web page on the planet. Index.html. It's so awesome, I'm not even going to test it or preview it or anything. I think it's pretty cool. So if I'm ready to deploy this, I just type now. And what it's going to do is it's going to take whatever's in my folder, figure out what's going on, and it's going to deploy that to the cloud. And it's there. Pretty cool. If it's a Node.js app, let's make it a Node.js app. So let's make it a Node.js server. Type a little bit. So server equals HTTP. Create server. Okay. Okay, so we got our little Node.js app. We're going to npm init, and we're going to say npm, let's do json-i-f package json-e this dot scripts dot start equals node server.js. Okay. So now let's deploy that. And so what it's going to do is it's going to say I have a package JSON. It's going to see that I have a server.js, and it's going to actually deploy our node server into the cloud. And you'll notice that it's a different URL than the HTML URL. So now if I paste that in my address bar, we should see hello world. The other side is if you have a Docker file, WordPress, Ruby, any kind of application that runs in Docker that meets 12 factor app standards, you put it in the folder, type now, it's going to deploy. It's just that simple. Now, if I want to alias that to a better domain, I can just do now alias, paste in my deployed app, and say, let's say syntax con demo.now.sh. And now.sh is a domain that everybody gets, and now that's deployed, right? Let's see. Syntax, let's see. Didn't keep. So syntax con demo.now.sh. All I did was change the alias of that URL to that immutable deploy. Now, if I wanted to buy a domain, do now domain buy, and let's do twilson63xyz. So I can purchase a domain with one line, and $3, sure, I'll spend $3 on that. And it'll take a little bit to purchase. But while it's doing that, one of the other things you may notice is, see this HTTPS here? It automatically did an SSL cert for my site and put it around HTTPS. And it's also HTTP2 compliant. So if you use HTTP2, all now services run off of HTTP2. So now my domain's available. So let's see if I can alias my project here. Okay, let me figure it out. So now I need to find out what my project name is, so I can do now list and I can say now demo 2, and it'll provide me a list of all of my projects. So I've got this one here that was deployed 3 minutes ago. Let's grab it. And now let's do now alias. And we paste in our immutable build of our project. And then we're going to say, syntax demo .twilson63xyz. Okay? Hit enter. And what it's going to do is it's going to verify the DNS, and then it's going to deploy that URL around and generate an SSL certificate for me, and usually about 5 or 10 minutes around the world, which is pretty cool. Because, just bought a DNS, built an app, shipped it around the world, and created an SSL. That used to take me a week, like 4 years ago, right? Maybe not 4 weeks ago, but it took a while. So that's sort of now, and hopefully it will finish there, but I know I'm short on time. So I suggest you try it out and see for yourself. Again, it's free. It doesn't hurt if you want to buy domains. You create an account for $15 a month. You can cancel that account. I've canceled them and restarted them, and it's a lot of fun. So that is now JS in the world of immutable functional JavaScript. There's also more. So you might say, well, what about secrets? How to view your logs? All of that information is just one line away with now. And it supports teams, so you can have teams to manage your deploys. So anyway, to recap, I suggest looking at your stack, but also looking at Tachyons, Randa, and now, because I think these things are just as important as, or things like them are just as important as sort of the React or Node or CouchDB. So with that, thank you.